Mr. Bruno.
Okay. So I hope, girls, you can see that you view the questions. We want us to pick up one question and then we answer it immediately. We are trying to start from simple questions. Here we are basically addressing calculations, and then it will actually form the end of our lesson and we move on to the next topic next week. Okay, so do that quickly and then we move on.
Mr. Sal.
Yes, Teacher Javila.
Are the questions clear?
Very clear.
Okay. So let them write number 1. We go through it. They will write number 2 like that.
Maybe they copy at once. Is it okay? Like they copy at once?
How many minutes are we giving them to copy?
Okay,
and there are those that come in a little late. I don't know.
Okay, okay. Let's do question by question.
Let's copy as many as they can. When we start solving, we shall start.
Okay.
We are giving them 5 minutes, I hope, to do that.
Mr. Chakonye, your hand is up. Unmute and.
Good morning, Mr. Sali and the entire team.
Good morning,
just
Mr.
requesting to be unmuted, please. I'm just requesting Mr. Olka to unmute me, that's all. Thank you.
Okay, all right. Mr. Bruno, I believe.
But Mr. Sali.
Yes, Mr. Chakonye.
I was wondering why, but because there were those questions that we had put in the Google Classroom. Wouldn't we have given these as supplementary questions so that we maybe save a bit of time?
We wanted to, I think, just do some more calculation because most girls were still confused last time about the density bottle. Just a few.
What I was saying. What I was saying was that we already had some questions already that were up there. Couldn't we use those for more practice so that perhaps these become more questions for practice for them later on as a way of saving time?
Go through the ones on the Google.
Mr. Chakon.
No,
Mr.
yes.
Chakon.
I can hear you.
May you get in.
The questions that are on Google Classroom are the ones on density bottle, isn't it?
Okay, some of them, yes.
No, the latest you sent.
Yes, that's right.
And when we looked at their syllabus, density bottle somehow comes a little later in ACMIDS. So we thought we shall get it again when we get to ACMIDS principle.
Okay, no problem.
No, number 4 here, we have 4 questions. Number 4 is to do with density bottle. We've tried to get a very straight one. Yes.
It's straightforward.
Otherwise,
it's okay.
Yes, that is the reason.
Agreed.
What are you
doing? Yeah, 2 minutes.
We're going to solve from. I've left some space down.
Job shifting. One part of that blackboard, they don't see it.
I know, but I think we can start. We do not have the number 4 already. I don't know.
Okay. And cut working space.
That is where I left.
Okay.
If not, you open. I think we have about one minute to go. Now, number 4, the other part of number 4 is on the other side. Let's first do with the first 3, at least, and this part of number 4, leave some space for more data.
Good day. Girls, we are starting off with question 1. And I hope you can view where we are going, the space where we are trying to answer question 1. So, Mr. Sali, please unmute for us. Somebody picks for us our data. Somebody who has put up an arm.
Mr. Sally, are you there?
Speak for me.
Kirabo Hope.
The question says, what is the mass of a cube of copper of side 2 centimeters, into brackets, density of copper is 9 grams per cubic centimeters. I think here, since the density is 9 grams per cubic centimeters, the volume is going to be 2 times 2 times 2. Since they say the side is 2 centimeters.
So,
Okay, so we first find the volume. Chirabo is telling us to first find the volume. Since it is a cube.
Volume is equal to L times W times H, which is equal to 2 times 2
times 2,
which
is 4 times 2, which is 8. 8 centimeters cubed.
That is our volume.
Then since density equals mass divided by volume, we get, no, since mass equals density divided by volume, we are finding the mass.
Yes, we are finding
when you rearrange that formula for density and make mass the subject, what does mass equal to?
Mass is density times volume.
Very good. You've been saying divide by. Continue.
Giving us 9 times 8.
And what is our answer there?
The answer is 72 grams.
Very good. Thank you so much, Chirabo.
You're welcome.
I don't know whether we have people with questions. If you're not having a question, kindly put down your hand for now. Okay, I think it was clear because I'm not seeing any hands up. All right, now if you're ready to take us through number 2, put up your hand. Crown put up her hand first.
I hope we can erase number 1. Yes, can we remove number 1, the solution for number 1?
Okay, maybe 1 minute for Crown. First, just hold on for a few seconds for people to jot down.
It's okay.
Yeah, but you can keep yourself unmuted.
Okay.
Okay, I think number 1 time is up.
Yes. Okay, Crown.
Okay, number 2 says, what is the volume of 60 grams of wood given the density 0.6 grams per cubic centimeters? So they've given.
First, pull out what you're given. Mass is what?
So they've given us the mass as 60 grams.
Yes.
They've given the density as 0.6 grams per cubic centimeters.
Okay. How do we proceed?
To find the volume, the formula to find volume is mass over density.
Volume. When you rearrange the original formula of density is mass over volume, it means that volume will be mass over density. Very good.
That will be the mass, which is 60 grams, over the density, that's 0.6. And the answer is 100 centimeters. Sorry.
100 centimeters cubed. Okay. Thank you so much, Crown. I want to.
Before they go very far, there is this small suggestion. Usually we write this as mass, write this as density, write this as volume. I don't know how many students know that triangle. If you are looking for density, you cover density. If you are looking for volume, you cover volume. If you are looking for mass, you cover mass and multiply. So I believe most of you know that triangle from your primary, secondary school. It is simple triangles to give you these three.
You can leave it there.
The formulae for whatever you are dealing with. So in this case, we are finding volume. So we covered volume and it is mass over density. So I believe it helps you quickly to handle such simple problems.
Thank you, Mr. Sanjay. Okay, I think these two want to contribute to number 3. Let me pick Kahunga Charity. Okay, thank you, Bruno. Charity, I've unmuted you. I hope you want to take us through number 3. But if it's a question that you have.
Teacher, I wanted to ask you to first take back to the questions so that I can copy number 3. Thank you.
So the rest of you also who had not copied those questions, take this opportunity. I know some people come in late. Number 3 and 4, copy even the part of number 4 that is here. Okay, as she copies, Vanessa, maybe she has a question. Vanessa.
Teacher, I wanted to answer number 3.
Okay, let's wait for just a few more seconds. There are people who came in late and they are still copying, but you're going to answer it. Charity, can we move on?
Yes.
Okay. So at Kunda, over to you. You're guiding Mr. Sanjay on what to do.
Okay, the question says 100 centimeters of water weighing 100 grams was mixed with 100 centimeters of seawater weighing 103 grams. Calculate the density of the mixture. Okay, we first write the volume of the water, which is 100 centimeters, and then the mass of the water, which is 100 grams. Then we write the volume of the seawater, which is 100 centimeters cubed, and then the mass of the seawater, which is 103 grams. Then we have to find the total volume. So we write volume of water plus.
First give us the formula for the density of mixture.
The density of mixture is equal to the total volume.
Total what?
Total mass out of total volume.
Yes.
Then we write that, then the total mass, we add 100 grams plus 103 grams.
Yes.
Which gives us 200 and, okay, out of the total volume, which is 100 centimeters cubed plus 100 centimeters cubed. And then you get 203 grams out of 200 centimeters cubed.
Okay. 203 grams out of 200 centimeters cubed. What is the final answer that we get?
You get, I've not yet calculated it. Let me.
Okay. Okay. That is 1.015. I think it is 1.015. Okay, we've got it as 1.015. I'm expecting some questions here. There are people who requested us to do a number on this. I'm seeing Hosanna. Thank you so much, Vanessa. Let's pick some questions. Hosanna.
Excuse me, teacher. I have just joining. I was requesting for you to view like the whole board. I want to just screenshot.
First, screenshot that side of the questions. And then I'll turn back to the other side. Nantale. Nantale.
Excuse me, teacher.
Yes.
The question was on number 1.
Yes.
When we got the mass, we multiplied. But then I didn't see anywhere we squared or cubed. So I'm confused.
Why would we square, in your opinion? Nantale, why do you think we should square? We don't just guess. Why do you think we should square? Are you seeing where I'm writing? Nantale, are you seeing where I'm writing?
Yes.
This is the triangle Mr. Senjebe asked us to use to make our lives easier. This is, the M stands for mass. This is D, standing for density, and then V for volume. It helps us with those formulas. Now, the common one we know is the one for density. So when you cover density, density is mass divided by volume. Then if we want, now number 1, we were asked to find the mass. So when you cover the mass, it means now that we are multiplying density times volume. Number 2, if you remember, yeah, it is on this. Nantale, they told us it was a cube of side 2 centimeters. So we had to first find the volume by length times width times height, and all of them were 2, 2, 2. So when you multiply 2 times 2 times 2, we got 8. And then we now use this. Since we wanted mass is density times volume. The density was given as 9, and the volume, we had found the volume as 8. So 9 times 8 gave us 70.
Oh.
Is that okay now?
Are you now fine?
Yes.
Okay, so remember, for those who are coming later, just as a by here they wanted the volume. Yes, they wanted the volume. They gave us the mass. Mass as 60, density as 0.6. So when you cover volume, it means that formula for volume is mass divided by density. Our mass was 60. We divided by 0.6, and we came up with 100 centimeters cubed. Okay, I think Nanyanzi, you screenshotted that side.
Yes, please.
Now there's the other side.
We want to
go to number 4. I don't know whether if the continuation is on the other side of the board.
I don't know whether the girls are done copying question 3.
We finished.
Yeah, we finished 3.
Let me pick some few questions here. Namuli, you near?
Teacher, could you please repeat the explanation for number 3?
Number 3. Okay, the teacher is going to go through it again.
Okay, thank you.
Now for the rest who are listening, you could be completing the question 4, which is on the upper side there, if you can see.
Question 3 is asking for the density of a mixture, and that is the formula we have for density of any mixture. It will be total mass of the mixture divided by the total volume of the mixture. So here, our mixture is made up of water and seawater. So we captured information as far as the water is concerned. So for the water, we are given a mass, which I call mass of water, as 100 grams. And the volume of the water was given as 100 cubic centimeters. So we looked at also the sea water, and for the sea water, we had the mass of the sea water as 103 grams. The volume of the sea water was 117.
Could you please adjust your screen a bit so that what you're writing down there can be seen?
Oh.
You can raise up a bit. Okay, that's better. That's better. Thank you.
Okay.
That's okay.
So that is what we captured as far as our information was concerned. So since the formula is telling us total mass of mixture divided by total volume of mixture, we add the masses. Okay? So I'm going to use this other part of the board to complete the question. I hope girls are done with question 4 also. So I'm erasing this question that we don't have. We are done with. So substituting into our formula, the density of the mixture going to be equal to, can she tell me the masses? What do I do? Please, who was asking the question, let us add the masses and you tell me what to write. Unmute for me, Mr. I'm unmuting Daniela, she's the one who is very close to me. Daniela, tell me the masses again.
The mass is 100.
Daniela, so 100 for water plus
103.
13. And then for the volumes?
100 plus 100.
100 plus 100. So we got 203 divided by 200. Remember that these are grams and these are centimeters cubed. So this unit will be grams per cubic centimeter. And our answer was 1.015 grams per cubic. So we are handling mixtures slightly, but okay, it is a question that came up in your book, but here there are some things that I don't know whether we should go into when we are handling mixtures. But the type of mixtures we are handling are liquids that are not immiscible. You know, some liquids can get dissolved in another liquid. So here we are talking about masses that are immiscible, or liquids that are immiscible. They don't mix altogether because that mass can change if one liquid dissolves into another. So we are dealing with very simple questions that will give us mass of total mass divided by total volume. I think at our level, that's what we're going to stick to. As we graduate and we become more solid in our physics, we shall now go to more complicated questions regarding mixtures. That's what we're given at our level. I hope people understand it now. Are we okay, girls?
Yes.
Okay. I hope everybody has captured question 4. I want us to look at question 4. It is the one that involves relative density. Again, here, relative density, we are going to keep it simple, please. And before we handle this question, I want you to give me the two methods, the way we find relative density. I want you to first give me those definitions. What is relative density? And I want it in mathematical form. I don't want it as a definition. I want you to tell me relative density is equal to this or that. That's what I want. Unmute for me, somebody to define for relative density. Who can give us the formula for relative density? The first one that we use, number one.
Sandra, Vivian.
It is density of a substance divided by density of water.
So we learn is the density
Of a substance divided by density of water.
Divided by
density of water.
Density of water. Now there is also another definition where we stopped at. We also discovered that. I hope you can see the way I'm writing. And we also calculated. Now somebody, I want a definition using mass.
Sekiraya, Daniela.
I had a question. Like number 4, I never got number 4, the question for number 4.
Okay. Who is with us, please? Relative density of a substance. Somebody.
Mass of a given volume of a substance out of mass
of
a given volume
in a volume
of a substance
divided
out
by
of mass of equal volume of water.
Mass of equal volume of water. So, because these volumes are the same, that's why we use a density bottle. Because the liquid is first poured into a density bottle, then water is poured into the same density bottle. And we discovered that since the volume of the bottle is a constant, the volume of the liquid and the volume of the water will be the same. So this formula is actually more friendly because all you do is to measure masses. Masses are measurable compared, and when you are weighing masses, the values you get are usually more accurate than the values you get when you are measuring volumes. So that's why this option is a better option for finding densities of the substances. So if I want to get the density of the substance, what do I do? So if I look at this combination, can you tell me, make this the subject? I hope you can see what I'm writing. So density of a substance can always be obtained as the product of what? I want you to look at that formula, and I'm making the density of a substance the subject. So what will it be? Unmute. Unmute. Somebody tells us.
Lena.
Mr. Njeri, there are those putting up their hands. Can I give you some hands?
Yes.
Okay, they are giving me.
I see Charity. Charity's hand is up for some time. Charity, do you have something to say on this? Okay, Charity does not seem to be there. Ndagano Queen. Ndagano Queen, your hand is.
Charity has come on.
Okay.
We would say relative density times the density of water.
Okay, thank you very much. So this will be relative density. I will use relative density times the density of what? Of water. Please, whoever wants to know information about relative density, this is what is important for us to capture. Try to capture this information, then we are going to go through the questions that will help you to understand the relative density. And we're going to keep them very simple for your level because the relative density will happen again in another topic somewhere when you have again matured to understand it better. But at the moment, let us keep it as simple as these three equations. I hope you are fine. So those who did not see question 4, we are rewriting it again so that you can capture it, but please screenshots will help you a lot so that you don't over delay and you also have the information.
Mr. Senjebe. Mr. Senjebe.
Yes, sir.
Adjust the screen a little bit so that upper
Madam
well, yeah, maybe slightly up so that the summary can be captured. Okay, that's better now. Okay, slightly up.
Up. Oh, yeah. Okay.
There.
I think that's okay.
Okay,
That is.
I think that's fine. They let them not. That's much better. That's much better. Thank you.
That's what we are going to be using.
Okay, let them be captured. Okay, Mr. Chakonya, I hope they finished. That question number 4 is there. So for those who had not got it yet, please take a screenshot so that Mr. Senjebe can continue with the working. In the meantime, let me see, Nakaliowa Yvonne.
Teacher, I had left my hand down.
Madam Javila.
Yes.
Yeah, let us request those ones whose hands are up to permanently to put them down. There are those whose hands are up all the time. Can they put them down and raise them up where there is need?
There is a
like Charity's hand has been up, Rukia's hand is up all the time.
Yes, Atamba. Let me pick Atamba. She had her hand. Yes, Christine.
I had left my hand up. Let me lower it.
Analule and Charity, I think it is the same thing for the two of you.
Charity, your hand is up permanently, put it down.
Daniela, have you seen question 4? And the rest that came in late, please take a screenshot. We want to complete. Daniela.
Yes, teacher, I've seen question 4. Thank you.
All right. Okay, now I'm switching to the other board so that we continue with the working.
Okay. From the information, can we tell me how we can capture the mass of the water? How we find the mass of the water? Remember, we say that it is the same as mass of water plus mass of density bottle minus mass of density bottle. I've given you the mass of the water. So, which is the mass of the water plus the density bottle. What mass is that?
Let's pick Chirabo Hope now to say something.
Chirabo Hope.
Chirabo Hope, submit. Is not ready, maybe. Nasolo Bethel. Nasolo unmute.
The mass, to get the mass of the water, you subtract the mass of the density bottle filled with water from the mass of the empty density bottle, which is 55 grams minus 30 grams.
And what is our result?
25 grams.
Okay. 25 grams. Thank you so much. Now we also need the mass of the liquid X.
Lena?
The mass of liquid X plus the mass of the density bottle is 370 grams. And the mass of the density bottle alone is 30 grams. So the mass of liquid X will be 370 grams minus 30 grams, which is 340 grams.
Thank you, Lena.
So we are going to look for the relative density. Will be equal to mass of what? I'm looking for the formula. Relative density of X will be.
Maybe Atukunda can say something. Atukunda, give us the answer.
Relative density of liquid X is equal to mass of liquid X.
Vanessa, unmute.
Out of mass of given volume of water, of equal volume of water.
Okay. So we substitute in our formula.
What is the mass of liquid X? There was a Mirembe Emily who again disappeared. Mirembe Emily, can you? Okay, there is Abigail Akisa.
It's 340 grams divided by 25 grams.
What is our answer?
Anyone who has worked out the answer? That is 4 times. Let me see my spotting. That is 4 times 2. So 13.6. I think it's 13.6. Louise Kwagala. Where has Louise disappeared? Okay, Birungi Anita. Birungi Anita?
It's 13.6.
Okay. Okay.
So we have found the relative density. What is the question asking us?
They want the density of the liquid.
What is the formula?
Let me pick someone here. Mainja Maria. Mainja Maria. Mainja, are you the one?
So density of X is equal to?
Okay, I'm seeing Phoebe.
The density of water. Relative density of water. Relative density of substance times density of
water. Very good. So can we substitute? What is the relative density?
13.6
times
was 1 gram per cubic centimeter.
Okay, and what is our final answer there?
13.6 grams per cubic centimeter.
Thank you very much. Okay, now I only want people with questions to have their hands up. If you have no question, kindly put your hand down. Please mute whoever is okay. So I'm assuming. Who is this one? Please mute yourself.
Mute so that we can.
I only want people with questions to put their hands up. As I try to get the whole screen from up. Okay.
Nasolo's hand is up.
I'm not seeing her on my screen. Maybe you can unmute, ask her to unmute from that side.
She has disappeared. Let's go. Ario, there's Ario there.
Ario Esther. Ario Esther.
Teacher.
Ario Esther.
Yes.
Yes. Teacher, there is this question which teacher Chankonye, teacher Richard gave us. Number 4. Number 4 is a little bit disturbing. Misses the units are not the same.
Okay. Okay, let's first get questions on these numbers. If there isn't, then I think we have some time. We can go to that one. So I only need questions from this last number here. Then we'll go to the other one. So Ario, put down your hand, please. Nalule Rukia.
Sure.
Yes.
Where do you use like is it the same case with the density bottle when they only give the volume, or you use like this thing of 1 kilogram is equal to 100 grams like that? Is it the same case with the density bottle?
I've not picked your question.
Are you asking about units?
No, not units. Like if they give you a question, like where there is mass, they put the volume, only the volume. Do you use the same thing like here for density bottle, or you use 1 kilogram is equal to 1,000 grams and 1,000 grams is equal to 1,000 centimeters cubed?
I think she's trying to get a different formula.
Okay, Mr. Senjobe.
Yes.
Mr. Senjobe.
Isn't she getting another formula?
For me, I don't understand the question because she's talking about mass and mixing it with the volume. I don't know how.
No, not
No,
like
Mr. Senjobe.
that.
Yes, Mr. Chakonye. Let Mr. Chakonye say something.
I think what that student is saying, she's referring to a particular case of water only. The scenario she's talking about applies to only water because she's saying 1 kilogram is equal to 1,000, 1,000 cubic centimeters, which is 1 liter. It is a case which works with water only because the density of water is 1 kilogram per cubic meter. So the scenario works with only water in particular. It may not apply to other liquids. She's relating the situation of water to others. She was, I think, wondering whether it would work to other situations.
Okay,
because
thank
1
you.
kilogram of water. Thank you.
Thank you, teacher. Numbers, Patricia. Numbers. Yes.
No, you multiply times 1.
We multiply by 1 because we were told that the density.
Okay, why times 1 gram?
Yes, we multiply by 1 because we were told that the density of water is 1 gram per centimeter cube. And Mr. Senyo labored to get to this formula, that the density of a liquid or a substance is the same as the relative density of that substance times the density of water. So in this case, the density of water was given in the question as 1. That is why. If they had wanted the answer in kilograms per meter cube, they would have given 1,000 kilograms per meter cube.
Okay.
Akampulira.
Teacher, I'm just requesting that you re-explain for me how you got the mass of liquid X, because I'm stuck.
Mass of liquid X was obtained from the mass of the liquid density water having liquid X minus the mass of the density water alone. I mean density bottle, sorry. It is the mass of the density bottle having liquid X minus the mass of the empty density bottle. Is that clear? Mass.
Yes.
Is it clear?
Yes, sir.
Okay.
Look at the question. Look at question they've given you the
Patricia, unless you have another question, please put down your hand. Even Mercy, unless you have another one. I'm seeing Chirabo Hope. You've been answering questions. I don't know whether you just forgot your hand.
No, excuse me, teacher, I had a question. I've
Yes.
understood the formula for finding relative density, which is mass of liquid divided by mass of liquid volume, but I'm that formula has kind of made me get confused. What's the meaning of the part that is okay? Like, you know, when they say that the relative density equals mass of a liquid out of mass of equal volume, what does that mean? I'm kind of confused there.
It means that the density bottle that was used to measure the mass, okay, water was put in a density bottle. Is that okay?
Yes.
And its mass was noted. Then they removed the water and put another liquid X in the same density bottle. And then they got its mass as 370. So the mass of water plus density bottle was 55. When they removed water and put another substance, this time the mass was 370, but the bottle is the same. We can assume this is the bottle we used. We fill this bottle, measure the mass, we fill it with water, measure the mass, and it gives us 55 grams. Then we remove the water, put liquid X here, the same bottle, fill it now with liquid X. And the mass is this time 370. So what they are saying, equal volume, the mass of an equal volume, is because that bottle that was used was the same. So the volume is the same for both the water and the liquid.
Oh, okay, thank you.
Finally, Charity. Charity.
Okay.
Charity.
Go to Mr. Chakonye's question.
Charity is not saying anything.
Excuse me, teacher. I just wanted to say that I had used another method to.
Did you get the same answer?
Teacher? I just wanted the density of X. I found the volume of water, then the mass of water, then after I found the volume of water.
Did you come up with the same answer? Charity.
After that, I found the mass of the water. Then since the volume of, yes?
Did you get the same answer?
Can you hear?
Yes, I'm also asking you, did you get the same answer?
The same answer.
Hear me.
Okay, that is okay. We shall not go through your method, but it is correct, though it may be a little longer. It is very lengthy, but it is correct. So we are not going to discuss it here, but you can be assured you'd be marked correct.
Okay, then I also wanted to say something else about the triangle that Mr. Senjove explained. Yes. I just wanted to give another clue. Like someone may ask herself that, how do you know that mass is in that position and density and volume? For us, our teacher in primary told us you can just use mommy, daddy, V station, then you can know the position. Like you put mass first, then density on the left, then volume on the right to give you mommy, daddy, V station. That's all. Thank you.
Thank you so much, Charity. So those who can use Charity's Formula for MDE, well and good. Okay, there's someone who asked about the other question, Mr. Chakoni's question.
Mr. Senjove. There you go. Now,
okay, Mr. Chakoni,
okay.
can you please share your
Yes,
screen?
please.
I have that question.
Okay. Thank you very much. Actually, to alleviate the students' fears, it was, I think, an oversight. It should just be kilograms everywhere. But let me get to your question quickly anyway.
Okay.
Yeah.
Okay.
As you're getting
question, I want to talk about mommy-daddy station. Is that okay?
A question.
No, let's talk about mommy-daddy station. Mommy.
Teacher.
Yes.
There's a question. Eunice, yes?
Teacher, I was still confused with, I was following your method, but the measurements, I didn't really get it with the screenshot for the water and liquid X, bottle with water and liquid, bottle with liquid X.
There is the question. Please. Screenshot. Mass of density bottle is 30. Mass of density bottle with water, 55. Mass of density bottle with X, 370.
Thank you, teacher. I've got it.
Okay. Mr. Senjo, we're back to you.
Okay, Mr. Chakoni, when you're ready, you tell me.
No, I am very ready. As soon as you unmute yourself, I'll be there.
Your question is more important than this formula triangle.
This mommy daddy.
Okay, it's there.
Okay.
It was showing grams around it. It was showing kilograms around here. The mass of the density bottle with the water was indicated as kilograms. It should have been grams. Just I've edited it actually.
Okay, we can go through it, I think.
Okay, time is not our best ally, but let's try.
We can pick they already have the question, so let's just pick the basic, the key points.
Okay. Okay.
Density of liquid, D of L.
Density?
D of L, just put D of L, 1.2 grams per centimeter cubed. Grams per centimeter cubed. Volume of the liquid is 50 centimeters cubed. We are picking the key information from the question because they already had the question. It's mixed with another liquid of mass. So the other one was liquid 1.
Yeah, this is liquid 1.
Then liquid 2.
So can I put this in 1?
Yes. The second liquid has a mass of 40.
Mass is 40 grams.
And density is 1.6 grams per centimeter cubed.
Density is
1.6 grams per centimeter cubed. Find the density of the mixture.
So here we need to use mommy-daddy station. Mommy-daddy station. Our interest is in mass. So M1 is D1.
Mommy, unmute yourself, Sebo.
Which gives us.
Excuse me, teacher.
Yes.
Mommy Sally seems to have a challenge. Mr. Sally, can you unmute yourself, sir?
It may be misunderstood.
Excuse me, teacher.
You're right. We need to keep it formal.
Yes, please.
I had a question, but it was for number 5, the same activity.
I need to answer the first question about pictures first.
Okay.
We're trying to go the time.
I think okay, but I think your problem was
units.
So yeah, the units, they are all supposed to be grams.
Not there.
I want to answer this one for which the rest.
Just wait, Mr. Senjewe, there's a lot of interference. Okay.
Students, can you unmute yourselves there? I mean, mute yourselves. Some people are really
quarreling in the background. 25. Okay, Mr. Chakonyi, can you view what Mr. Senjebe is doing? Hey, she meant number 5, please.
But even this question is okay. We shall look at number 5.
Madam Jalil, at the moment I don't.
You're not seeing it.
Did
I remove.
Hey, Mr. Chakoni, it is you to unshare.
Yes, please.
You unshare maybe and you see
Okay,
what
okay. Okay. Yeah, that's all right.
So, guys, we are sorry we picked the wrong question, but I think this question is also important because it is, I think, method of mixtures. In liquid 1, they gave us the density and the volume, and we have captured that. So in this C, we realize that we need the mass. So we have got the mass by using that formula, density times volume, and that is our mass. Now, in liquid 2, they gave us the mass and the density, but we are missing the volume. So we calculate the volume using that equation again, and that's what we get as the. So now we are going to get the density of the mixture. I'm going to factor here. Density of mixture, remember, is given as mass over total volume. So in this case, our total mass will be M1 plus M2, and the total volume will be V1 plus V2. So we substitute and you get, where is the total mass? Total mass has been calculated as 60 here. Where is the other mass? This mass was given as 40. Then where is the first volume? The first volume was given as 50. And where the second volume we have calculated, it is given as 25. So
that is
this gives us 100 over 75. And this will be grams per cubic. And I think we can calculate that, which is 1.
250. 1, 2, 3. 1.3.
1.33. Yeah? I think 1.33. So
yeah, 1.33.
And this will be grams per cubic. So we have answered only one question in Mr. Chakonye's, and it was mixtures. So please try to capture that screenshot, and then we are stopping there.
Mr. Apio specifically had wanted number 5, but Mr. Chakonye has corrected it. All the units should be in grams. So go back and try it. It will now work out. It's already 5 minutes past.